Okay, use the trapezium rule with ordinates t equals 0, t equals 3, 6, 9 to estimate the distance the particle travelled during the experiment. Now you need to remember as well, with a velocity time graph, the distance can be found by working out the area. Okay, if you work out the area under the graph, you've got the distance. Okay, that gives you the distance covered. Now ordinates are 0, 3, 6, 9. So at 3, I'm going to draw a line here. At 6, I'm going to draw a line here. And at 9, well, it goes to the origin, doesn't it, there? Or goes to the axis, rather, and the same here at 0. Okay, that at the origin there. So I don't need to draw a line there. What I'll do, though, is I'll join up then, okay, these lines. And you can see that there's a trapezium being created here. Okay, if you turn it on its side, it's easier to see the trapezium. Yeah, these two sides here are parallel. Okay, now, if I join them up, it actually works out to be a triangle, doesn't it? Okay, because there's no height here. If there was a height there, you'd have a trapezium. And the same here, it's a triangle, isn't it? Okay. Right, so I need to call these A, B, and C. Okay, and even though it's a triangle, I can still use the trapezium formula to work out A. Okay, so the area of A will be, well, the formula, remember, is half A plus B times H. Okay, that's the formula. So in this case, half, well, your A is 0, isn't it? Because there's no length to that side. Your B is the length of this side here, which is 8, times then the height between them, which is 3. Okay, so if you work that out there, it comes out to be, well, half times 8 times 3. And notice as well, that's like half base times height, isn't it? You've got your triangle, really, which is what it is. You think of that as your base, and that's your height. And you can work out the area to be 12. Okay. B as well then. The B might be clearer to see as a trapezium here. Okay. So you've got your this side here, which is 8, and this side here, which is 5. Right. So 8 plus 5 times the distance between them, which is 3. So you get half times in there is 13 times 3, and if you work that out, you get 19.5. And then for C then, half, well, that's your A side there, so that'll be 5. That's 0, okay. And then times by 3 between them, so you get half times 5 times 3, which is 7.5. Add them up, okay, and you get your total then, and that will be distance, right? So that'll be given in terms of meters then. So I think it comes to 38 there. In part 2, it says then, by considering the graph given, state how you could improve on the estimate for the distance the particles travel. So we've used the trapezium rule, but if you notice, the ordinates are quite far apart, aren't they? Okay, which means that there's a lot of area here that hasn't been calculated. Okay, now had I made the trapezium smaller, okay, so you'd have more trapeziums. Okay, so I could have had another ordinate there, couldn't I, in between somewhere? Okay, and it would have been a trapezium which would have covered some more of this space. So with more ordinates, you get a more accurate answer. More accurate solution for the area.